Hello again. So today we're going to run through another complex unfamiliar question for methods. This is from the QCAA external exam paper 2020, paper 1, question 19. So question says the horizontal point of inflection is a point of inflection is also a stationary point. So we know that. So it's SP. So today we're going to find out what is the K. So this is the K. We don't know what K is. Well, so we need to decide the value for K so that this function has the only one. So the key is only one horizontal point of inflection. So, okay, first of all, we need to know the point of inflection is when. So the P or I occur when the derivative function must be equal to 0. So let's first, we need to find the derivative of the function. So this is the key. And we make it equal to 0, so then we can decide the value for K. All right, so first of all, I'm going to simplify the fx. So the fx, I'm going to put 1 over K in the front, log x. Then I'll put a K in outside the bracket. The x divided by x plus 1, I'm going to put x plus 1 minus 1. So the second bracket, I'm going to separate, I'm going to plus 1 minus 1. So the reason is you can see my function is simplified to, so I'm going to say inside that bracket is 1 minus 1 over K plus 1. So instead of x divided by x plus 1, so we separate it into, because those two are the same, so we make equal to 1. All right, so now we expand in brackets. So 1 over K log x negative K negative negative plus K times by x plus 1 to the power of negative 1. So that's the simplified version of fx, and we're going to do differentiation. Now, why we need to do that? Because this guy here is constant. So constant, when you do constant, the derivative function is very hard to do without simplifying. So let's do differentiation. So first one, 1 over K, we just copy, then log x is become 1 over x. Derivative K becomes 0, so we don't need a 0. Then you put a negative 1 to the front, become negative K, x to the power, x minus 1 to the power of negative 2. So I'm going to put neatly put together minus, I'm going to put a K on the top. So I'll put an x plus 1 square on the bottom. So what I'll do is I'm going to make common denominator. So we got kx, x plus 1 squared, and I've got on top. All right, so we say we will let equal to 0 because we want to solve a stationary point. So make equal to 0. So therefore the top, the numerator must be equal to 0. So therefore the x plus 1 minus k square x equal to 0. So I'm expanding that bracket, x squared plus 2x plus 1 minus k square x equal to 0. That one equates to x squared plus 2 take away x squared x plus 1 equal to 0. So this is a quadratic. So we know quadratic equation, if you want to find that the only one solution means the discriminant. So we call delta. Delta is b squared minus 4ac must be equal to 0. So that it's only one solution. So that's, we're going to say delta equal to b squared. We're solving that equation. B squared is a 2 minus k squared minus 4ac, which is minus 4, we equal to 0. So let's solve the equation, solve for that. So there's 2 minus k square x equal to 4. So that leads to 2 minus k square x must be positive or negative 2. So, sorry, yeah, we're going to take a negative square off. So that's, next step, we got a k square either to 0 or k square equal to 4. So these are two values for k squared. So the first one, we know k is 0, or you got k equal to positive or negative 2. So we got 2. However, so if you look at the derivative function, so if you look at the original function, you can see the k is denominator. So you cannot equal to 0. So therefore, k equal to 0 is not applicable because they're causing infinity. If you want to prove, say, because f, so when the k equals to 0, fx become infinity. So undefined. So therefore, we only can choose k equal to positive or negative 2. So if that's the case, we're going to put the f dash x into the formula we just derived from step here. So that's all right. So we substitute. So eventually my derivative fx will be x squared minus, because 2 minus 4, which is negative 2, plus 1. So now it's stationary. We're going to cause equal to 0. So we're solving for, this is a x squared, x minus 1 squared to 0. So the x must equal to 1. All right, so now we're going to test if it's a stationary or whether it's a maximum or minimum station with a P or I. So we're by using double derivative. So doing a second derivative. Second derivative become 2x minus 2. So when x equal to 1, we know second derivative at equal to x equal to 1 is 0. So therefore, the POI, point of inflection, occurs at x equal to 1 when a equal to positive and negative 2. So that's the only possibility. So this is the only solution for k, positive, negative 2. So x equal to 1 is the point of inflection. That's it. So if you liked this video, please give us thumbs up, or don't forget subscribe the channel so you can get more videos. Thank you.